Okay, so now we're moving on to section 2 where we're going to talk specifically about arteries. We have three groups of arteries. We have elastic arteries, muscular arteries, and then arterioles. And these groups are based off of their relative size and their function. So those are the things that you're going to be looking for to kind of compare and contrast these three groups of arteries. Which one's the largest, the smallest, and what the function of each of these are. So elastic arteries are really, really thick-walled arteries. They lie really close to the aorta and its major branches. So that's why they're also called conducting arteries, because they conduct blood from the heart to these medium-sized vessels. They're also considered low resistance when we're talking about blood flow. Because they're so large, they have a large lumen. And we'll talk a little bit more about resistance later on. So they're elastic arteries, so we would expect that they would have elastin in them. So the elastin can be found in all three layers or tunics, but predominantly the elastin's found in the tunica media, or that middle layer. So they also have some smooth muscle, but they're not active in vasoconstriction. So the elastic arteries are not involved in constricting or making the lumen diameter smaller, but they are active in vasodilation. They can act as pressure reservoirs because they can expand and then recoil as the blood is ejected from the heart. So if we're thinking about our blood pushing at a really high pressure from our ventricle out to, say, our aorta, we want them to be able to expand in that area, like for example our aorta, as they receive this high pressure blood that's coming through. So the purpose of acting as a pressure reservoir is to allow for continuous blood flow downstream, even between different heartbeats. Our next one is muscular arteries. So once we've passed our elastic arteries, remember that are closest to the heart, then they're going to kind of form into what we call muscular arteries. And these are also called distributing arteries because they help deliver blood to all of our body organs. Diameters range, so they're not always really, really large. These are kind of our medium-sized ones, but it's a range of medium, anywhere from a size of your pinky finger to the size of pencil lead. Most of the named arteries that you'll have to learn in lab are going to be muscular arteries. They have the thickest tunica media because that is the layer of the blood vessel that has the most muscle. So more smooth muscle we would expect to have in muscular arteries, which is why that layer is the thickest. Not as much elastic tissue. Also, these are the ones that are active in vasoconstriction. So if we want to constrict our blood vessels and make the lumen diameter smaller, that would be accomplished by a muscular artery. Okay, the final one is arterioles, and these are going to be the smallest of the arteries. So they only have a lumen that's about the size of 0.3 millimeters all the way down to about 10 micrometers. The larger of the arterioles, they're going to have all three tunics or layers. But if we're talking about our tunica media, it's chiefly just smooth muscle with a couple of elastic fibers in it. The smaller arterioles are going to lead to our capillary beds, and those are only a single layer of smooth muscle cells going around the endothelial lining themselves. Control into the capillary beds is accomplished by vasodilation and constriction of the smooth muscle in these arterioles. They're also called resistance arteries because they can change their diameters to help change the resistance to blood flow. And we'll talk about later on in this lecture for this chapter why that's so important. So the arterioles are going to feed into the capillary beds. So just as a recap, closest to the heart, we have our elastic arteries. These elastic arteries are going to merge as they get farther away from the heart and form the muscular arteries that are active in vasoconstriction. And then these muscular arteries are going to form smaller arteries, which we call arterioles, that are actually going to be the ones that are invading our tissues of our different organs all over our body.